Hello everyone, welcome to Excel Maths. I'm really sorry for a long wait. Was trying my best to recover quickly, and I think today I'm better and I can make a video on the last question of June 23 paper 3 shadow series, and this is the last question of mechanics. Okay, so let's get started. Very interesting, and it could be challenging if you struggle with moments. Yeah, that's true. Okay, let's get ahead. But yeah, it's not, again, I would say difficult. We have two methods. I don't know whether what method you opt at the moment, like, during exam. We have two methods, an easier one and the difficult one. So I might be including both the methods today, but you have to, like, what clicks at that time, that is the moment, like decision of the moment only. So let's get started. We have a question over here where rod AB has mass m and length 4L. So we have the mass of rod AB, which is given to us m, and length is 4L. So the length of the rod AB is 4L. Okay, the rod has its end A on the rough horizontal ground and its end B against a smooth vertical wall. The rod makes theta angle that we can see, and the rod is at limiting equilibrium. These are very important terms. What is limiting equilibrium? So limiting equilibrium, what do we mean by limiting equilibrium? That means your maximum F max, maximum frictional force is mu r, right? We might need this information later in the question. State the direction. First is for 1 mark, so obviously it's very easy. State the direction, left or right, on the figure above of the frictional force acting on the rod at A. So we have to think of the direction of frictional force, right? We have to think of the direction of frictional force, and I think we have to answer in terms of left or right. So you're wise enough to understand it's a rod, like simply just, practically, if you think, if you are placing the rod like this, chances of slipping, if it slips, it won't go inside. If it slips, it will go outside, right? To the left. So where the friction, but we have not to talk about the motion, the direction of motion, we have to talk about the friction. So the friction is going to be acting this way towards the wall, or we can say right side. So this is, let me just thicken the pen. This is just the direction of friction is. Correct. So the right would be the correct answer. And what is the reason for that? Because we have to give a reason for our answer. So we can say just to prevent it from slipping. So let me write it here. To prevent it from slipping. So we have friction force acting towards right. Okay, now for the B part, we have, B part is of 3 marks. The magnitude of the normal reaction of the wall on the rod at B is P. So that means this is the direction of a normal, which is P here. That is fine. And in an initial model, the rod is modeled as being uniform. This is what the question I've asked today. So what do you think? What is the importance of this word uniform over here? When it comes to be uniform, that means what? Did you answer that? That means we are going to be having center of inertia or center of mass acting at center, middle point. So when we just draw the center of mass, so the center of mass, like the weight will act at the midpoint, right? This is a shadow series, remember. So we can say when it is uniform, that means center of mass is at midpoint. That is uniform. We have done non-uniform things also in moments, right? Okay, so let's see what B part is asking us. By taking the moment about A, show that this is something. So we have to just focus on P, and P is something like this we have to prove. So over here, I'll be adding, if that is theta, this will also be theta. And so the force over here, let me thicken the pen again. The force over here and the force perpendicular. We are just trying to find out the components. Okay, so the force down there would be P cos theta, and this force will be P sine theta. That is good. And what else can we resolve over here? I mean, find the components of. So yeah, that's fine. We have uniform information given to us. So let's say, for example, this is the midpoint. Huh? So this is our weight. Weight would be mg. Okay, if this is mg, now let's resolve. So this angle would be theta. I mean, let me draw the theta. Theta is inside, okay? This angle is theta. And let me just write theta there. This angle is theta. Hope you understand it, okay? I mean, when you try writing something nicely, it never happens. This is what is happening with me. Okay, nice. It's better now. So it is theta, and we are going to be getting this to be mg cos theta. And what about mg sin theta? Mg sin theta, would it be that side or this direction? Yes, this is the right direction. So we're going to be having every time the cos theta and sin theta, they are perpendicular to each other, 90 degrees. But your main force should be inside, like if you draw it there, still it is 90 degree, but your force mg is not there, so that would be wrong. So it is surrounding the component should surround the main factor mg. So it would be mg sine theta this side, right? Now let's resolve. We have to think of P. So this is what is acting at the moment, and what exactly it is saying by taking moment about A. So by taking moment about A, so about A, we have to keep any force that is acting at point A, like F wouldn't be significant. We have just two forces, P and mg. So yeah, let's continue with that. So moment about A, for B part, we are going to be doing moment about A. How do we do that? Force times the distance, perpendicular distance. So what is the perpendicular force for this distance is? Distance is 4L, and this P sine theta would be the thing, right? Which is acting anti-clockwise. So this is the first thing we have. Maybe if I draw it with blue, that would be good. So with respect to point A, and then we have perpendicular to perpendicular distance, this mg cos theta is the another force. I mean, you are about to sit for your final exam, so I'm not adding any learning part here, but yeah, necessary information. So we always take force times perpendicular distance. So we have to go about A, any force acting on A that is not considered over there. So we have only two significant forces, which is mg cos theta and P sine theta. I missed P here. Why didn't you tell me before? It is P sine theta. Okay, nice. So we can say that because their direction is different, so they are going to be equal. So P sine theta is the force, and what is the distance? Distance is 2L. It is equal to mg cos theta, and what is the distance? We don't know. Yes, that's true. I also don't know. But we know that this is a uniform rod, right? I mean, it is modeled as uniform. That means this point is midpoint. If this point is midpoint, now Are you getting any thought? What is the perpendicular distance? It is 2L, right? From this point to that point, it is 2L. So we are going to be writing 2L there. Okay, now let's simplify this. We have to find out what? P. So P is going to be mg cos. Sorry, it was 4L. I mean, we should write 4 there because it was 4L. Hope you understand. I'm taking my words back. P sine theta and the perpendicular distance. So this whole distance, right? So this whole distance is 4L and that is 2L, right? So yeah, mg cos theta over sine theta, and let's make it 2L over 4L. So that would give us half. So we can write half mg cot theta. This is the value of P. Okay, now I'm not really going to be, for many a times I feel like, no, let's not show the mistake because we can't make mistakes. Is it really possible? So let me cut down my efforts and I'm going to be releasing it as it is. It happens, but I realized and I just made it correct. This is what happens with you as well, right? The most important thing is realizing. And yeah, this is a learning part. Rechecking is very important. Okay, so we got our answer. We got 3 marks. Now let's go to the next part. The coefficient of friction between the rod and ground is mu. And given that tan theta is 3/4 and we have to find out the value of mu. Okay, and it is of 5 marks. A lot of marks over there. How to do that? I'm just thinking. If you get any thought, for this thing I have 2 methods, very, very, very difficult method or easy method. So let me just give you the, glimpse of hard method. I mean, if it clicks, you can't save yourself. I'm truly telling you, this is exam time. When it's exam time, whatever clicks, you feel like, let's proceed, let's follow that. Hard method. Hard method would be resolving along the rod and perpendicular to the rod. So if you follow this method, it wouldn't be hard, I would say, but it would be tedious. Like, it would take time. It is perpendicular to the rod and it is along the rod. So if we try resolving forces along the rod, so let me just write all the forces first. First thing, let me read the question again. It is talking about mu, and it is talking about mu. That means we are talking about friction, and friction is here. We can't really go with find out friction without what? Without normal reaction. Did we discuss about normal reaction at any point? Yeah, normal reaction for P was there, but what about normal reaction for A? Because they are taking mu, that means there should be normal reaction. Okay, that's fine. So we are going to be adding, maybe let me add, some other color. We are ending up with colors. Let me take another color here. Okay, maybe the purple. So we are going to be taking, this is what, this is R, normal reaction at point R. Now, this normal reaction is opposite to the mg, like the weight. We have to find out coefficients. So if this is theta, we're going to be getting this angle to be theta again, and this will be r cos theta, and here we're going to be getting, in this direction, we're going to be getting, I will write very small here, r sine theta, right? This is r sine theta. Similarly, let's write the components of F, friction. So the friction, if it is theta, in the same direction we are going to be getting F cos theta, and downwards we will be getting f sine theta. And I think we have resolved all the forces, isn't it? So let me just write it here only. If we go along the rod, this is when we are going along the rod. Along the rod, we will be resolving our forces. So we have to focus on all the forces which are either going this way or that way, right? Not up or down, no, just along the rod. So we can see r sine theta and f cos theta, they are, in the same direction. F cos theta, the sum of these two is going to be equal to mg sine theta plus p cos theta. Okay, and if I say perpendicular to the rod, these forces, so we're going to be getting all the top forces. Top forces are r cos theta plus p sine theta, that is equal to f sine theta plus mg cos theta. Okay, so what we're going to be doing, let me take these two equations we have written. Let me take these two down there and show you what are we doing? We are solving the same thing, but with not the hard, but like it's going to be taking more time for sure. Okay, so I'm just adding it here like this. So now in the same question, we have one more information given, that is tan theta is 3/4. So if you have tan theta 3/4, you can find out sine theta and cos theta. So over sine theta is going to be 3/5 and cos theta will be 4/5, right? So out of these two you can substitute the value anywhere and just get the answer. I mean, we have to find out mu there. So we know that F equals mu R. So if you know F and R, you're going to be dividing them and find the value of mu. This is what we have to find out. Okay. So let's take the first equation, that is r cos theta plus p sine theta, substituting the values there. So cos theta is 4/5, so we're going to be getting 4/5 of r plus p is half mg, sine theta is 3/5 times half mg, and cot theta is 4/4. Sorry, 4/3. That is equal to f sine theta is 3/5. Let me write it like this. So we can write it 3/5 of f plus cos theta is 4/5 of mg. Okay, we can, I guess, simplify this. So 4/5 of r plus, we can, okay, let me write it down. Or no, I'm not going to be writing. Let's divide by 5. And yeah, so we're going to be getting 4r plus, what it will give us, 5 divided by 5 and 3 and 3 and 2. Okay, so we're going to be getting 2 mg here, that is equal to 3f plus 4 mg there. So let's move them around. We're going to be getting 4r minus 3f, that is equal to 2 mg. Let's go there. What was r? R and mg, aren't they like r and mg? They are balancing each other. That means they are equal to each other. I is equal to mg, isn't it? So I is equal to mg, m capital 1, mg. So we can substitute that value. So 4 mg minus 3f is equal to 2 mg. Let's find the value of f. So f will be 1/3 of 2 mg. Correct? This is the value of F, and this is the value of R. So we have these two values, F and R, and we have to find out mu. So what mu will be? Mu will be F. Let me go back. 1/3 of 2 times mg, or can we say 2/3 of mg over R is just mg. That is going to be giving us 2/3. So this is the value of mu. But this is very long method, correct? Now let's see the quick, easy method. It's not like it will, like your marks will be deducted, not at all. So over here, we have, for the C part, 5 marks. Coefficient of friction between rod, you have to find out. We know that F max is mu R, right? R we know, which is equal to what? Which is equal to mg. And we know that P is equal to, this P was what? Because it was at equilibrium, uniform, everything, limiting equilibrium, everything was known. So we know that P is equal to F, right? What P was? P was half mg cot theta. So cot theta would be 4/3. So we can say F is half mg 4/3. That is 2/3 of, we can simply say it is 2/3 of mg. Okay, to find out mu, we're gonna be doing F over R, or F max over R, that is going to be the same thing, 2/3 of mg over mg. That is going to be giving you the value of 2/3, right? Correct. Because this thing was given that it is a uniform, it is balanced, equilibrium, everything was there. That means it's not moving, and it is balanced by the friction. And the frictional force is acting at this particular point, if you can see this point, and which is balanced by P. So we can definitely use this. Now let's go for D part, which is of 3 marks. So over here, find in terms of M and G the magnitude of resultant force acting at A on the rod, acting at A. So we have just two forces acting on rod, R and F. So let's draw it. It is asking about the resultant. I hope you'll be understanding. This is R and that's F. So the resultant force will be square root of R squared plus F squared, correct? So just substitute these values so that we can get what is R. R was mg squared and F was 2/3 of mg squared. So that is going to be 49. So what is that? 13. Okay, yeah. So 13 over square root of 13 over 3 mg, right? Or we can say 1/3 of root 13 mg. So this is what the resultant force is. Okay, so let's do the last part, E part. And over here we have a new model, and the rod is non-uniform this time. So non-uniform, that means the center of mass is not going to be at the center. So non-uniform with its center of mass closer to P than it is to A. So say for example, this is A and that is B. If it is closer to B, that means there are more chances for the slipping. If there are more chances for the slipping, so you're going to be getting the, what would you get? What would you get? If we have the moment of the weight, more chances for slipping, that means the moment of weight about A would be larger, isn't it? So if moment of weight about A is larger, that means you have to take this reaction to be stronger, I mean greater. You will say that this P is greater than, say for example, it's P dash. So P dash is greater than P, because if the rod goes non-uniform and our center of mass moves closer to B, then we have moment about A with a greater value, moment of weight. This is weight, mg. Moment of weight would be, so we can write, let me write it out here. So we can say the new value, we are assuming it to be P dash. P dash is greater than P as the moment of mg, or we can simply say weight of rod. Moment of weight about A would be what? Greater or smaller? It would be larger, right? I know you are smart enough to understand that. Okay, nice. So important thing, P dash is what? Just remember, P dash is the new one. P dash is going to be greater than P because the moment will be larger. Moment where it is about some point. Moment about A will be larger. Perfect. Thank you so much staying with me, going through all these questions. Bye bye. Take care.